Hello physics students, welcome to class today. Today we're just going to go over two examples relating to Newton's second law. In the previous video you all watched, you saw that the relationship that exists in Newton's second law, that the more force you apply to something, the more it accelerates, the less force, the less it accelerates. Also, the more mass an object has, the less or the harder it is for that to accelerate, or the less acceleration there will be on that object. Same thing, if there's less mass, it's easier to accelerate the object. Alright, so let's get into our example problems. In this example problem, a football is kicked. This is a foot, this is a football. I'm a terrible drawer. Deal with it. So your instructions, we are going to draw a free body diagram, find the magnitude of all the forces, and then find the acceleration. So if you're feeling confident, you could go ahead, pause the video, try it out, and then see how you do, and walk through it with me. Or just walk through it step by step with me, follow along, grab a scratch sheet of paper. Practice sometimes just writing it out. That muscle memory helps you retain that information that much better. So let's get started. Let's draw a free body diagram for this football. So let's imagine just a football. Oh gosh. Physics pony is now a football. Physics pony is gently sitting on the ground. And what forces are acting on our football here? Well, we have the force of gravity, always, right, pulling down towards the earth. And we also have the supporting force of the table, or the ground. And we call that the normal force, remember? So we know we have these two forces to start us off. Again, drawing a free body diagram, I want to make my circle or my box. I like circles. So we have our force, gravity. Our force normal as well. The arrows are about the same size. And should they be the same size, or should they be different sizes? If you said the same size, you're absolutely correct, because the football is just sitting on the ground. The forces are balanced, and it's not doing anything that exciting, right? Well, now what happens when we apply a foot to kick the football? We have a big force this way, right? And we call that force applied. Okay, so now is when things get really exciting, right? We apply a force, and now we have only three sides of force, and this arrow is much bigger than actually no arrow on this side, right? So we have a net force going that way. So we already know conceptually there's probably going to be some acceleration. And yeah, when you kick a football, it speeds up, right? You all know this from playing sports, things like that. You kick something, it goes flying. So let's go ahead and figure out. It says find the magnitude of all the forces, and then we'll find the acceleration. So let's go ahead and first find force gravity. So remember, force gravity is also known as the weight Alright, so we got the weight of our object, and our weight, or force gravity, is equal to mg. mg. Well, the mass is a half a kilogram. Gravity is 10, so 0.5 times 10. Sometimes I don't put units in my equations because I know at the end that as long as I'm putting in kilograms, as long as I'm putting in the standard unit of acceleration due to gravity, that I'm going to get the right units at the end. And 0.5 times 10 is 5, and any force, our unit should be in newtons. All right. Now, how the heck do we find normal force? Gosh. Well, man. Well, we know that if our football is sitting nicely on the ground, that those up and down forces should be balanced, right? Or equal each other. So it was, and it is, so this is just going to be 5 newtons as well. We're given our net force, or our total extra force is 124 newtons. Well, these cancel out each other, and so our net force is 124 newtons that way, which tells me that our applied force is 124 newtons. All right, now we need to find the acceleration. So now here is when Newton's law comes in. And notice what we've done before is, or we've done all of these steps before. We've found the weight, you all have practiced with that. You all have drawn free body diagrams and practiced with that. And you've found the net force before as well. And so we're just adding one more step and kind of putting it all together here. And so we know the sum of forces equals ma. So let's look. Do we know our net force? Yeah. Do we know the mass of the object? Yeah. And we're trying to find the acceleration. We don't have. So we're going to find this. So the next thing that I do is I just start plugging numbers into my equation. We got 124 newtons equals our mass times A. So to get A by itself, I need to divide both sides by 0.5. And when I do, it's dividing by 1/2 or multiplying by 2. And our acceleration equals 248 meters per second squared. So our acceleration is pretty big here. And yeah, rightfully so. Yeah, kick a football really fast and it speeds up really quickly in a short amount of time. So we have pretty big accelerations there. Awesome. If you have any questions on this, go back, watch the video again. See if you can't figure it out by looking through any of the other resources. And if not, come talk to me. I'd be happy to walk you through some of these problems and make sure you're understanding this. So we're going to move on to the second example because I can't answer your questions right now. It says a 6,580 Newton upward tension force, so tension pointing upwards, is exerted or applied to a 521 kilogram downward moving elevator. Find the acceleration. Well, maybe will give you one of these types of word problems on a quiz, test, something like that. So just showing me that you can think through all of the steps. Mostly we will be filling in boxes similar to your homework assignments. I will be on this one. But we're going to go through this because I think this is a great example. So let's draw a free body diagram is the first step I always want to do. So we'll start with our dot. So what forces do we have acting on an elevator? Well, we have gravity always, right? So we have down F, grav. And it says we have an upward tension force. So I know we have an upward tension force. And this tension force is going to be 6,580 newtons. Okay? So how are we going to find the acceleration? Gosh. Well, let's write out our Newton's second law. F equals ma, or the sum of the forces. So looking at this is where I'm going to find my acceleration. So I'm ultimately looking for that. We have our mass, which is 521 kilograms, and we don't know our net force, so we need to find net force. So see, I'm kind of working backwards from where I know I need to be and what equation I need to be using, and kind of work back towards the free body diagram to try and figure it out. So net force. If I was given gravity, I could just subtract the two or add them up in vectors and figure it out. But we're not given gravity, so we should just give up and go home or go to the beach or something, right? No, let's not do that. Let's figure this out. So force gravity, remember, is equal to mg. We always know g is 10, and we're given the mass, right? So let's put those into our equation. Our mass is 521 kilograms multiplied by 10 for a total of 5,210 newtons. So now I have 5,210 newtons down, and I have tension is 6,580 newtons up. Okay? All right, so I have more, right now I can see I have more going up than I do going down. So I'm going to have a net force pointing upwards. So I'll take 6,000, so my net force equals a positive 6,580 minus 5,210. $6,580 minus 5,210 equals 1,370 newtons up. So I have a net force of 1,370 newtons upwards. Okay, so now we have found our net force. So now we just plug in this equation to get our acceleration. Net force 1,370 equals our mass 521 multiplied by A. Now here we have A multiplied by 521, so we need to divide both sides by 521. And we find out our acceleration is 2.63-ish meters per second squared. All right, so we have found our acceleration. Now, which direction is our acceleration in? If you said up, you're correct. Because, and the reason being, remember the acceleration of an object is always, 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 always in the direction of the net force. So my net force points up, my acceleration is going to be up. One more thing, I want you all to think about this. Is this elevator speeding up or slowing down? Pause the video, take a guess, see what you think. Right. Hopefully you all have an answer in your noggins. If you said slowing down, you are correct. The reason being, remember, if an object is slowing down, the acceleration and the velocity are going to point in opposite directions. So, we have our acceleration pointing upwards. Our velocity, it says a downward moving elevator, it's moving down, and so that cable is pulling harder upwards to get that elevator that's moving down to slow down. All right. Thank you all for watching. I really appreciate it. Have a wonderful rest of your day. Please let me know if you have any questions, comments, concerns, or emotional outbursts. You have a good one. We'll see you next time.